Good morning, students. So this is our second video. In the last video I discussed about class declaration, creating objects and methods. In this video let us discuss about constructors and garbage collector. Constructor is used to initialize objects. So in the last class we have seen that to create an object we use the syntax class name, object name equal to new, then again class name with parenthesis. In the last statement I said that the class name with parenthesis is a constructor. It is used to initialize the objects, to create the objects. The name of the constructor must be the name of the class. So it is mandatory that the name should match. Constructors are similar to methods. There won't be any return type in the constructor declaration. Types of constructors. There are three types of constructors. One is default constructor, parameterized constructor, and copy constructor. Default constructor. The constructor without any parameters is known as default constructor. Java creates a default constructor if the developer did not provide any constructors. If the developer has not written any constructors, Java compiler is going to create a default constructor for you. So the default constructor is a constructor without any parameters, and the structure will be like this. Class name, I said that the name of the constructor must be the name of the class. So class name, parenthesis, then you can write anything inside, then close the constructor. Example. So if you remember about the box class which we created in the last video, it has got three instance variables: width, height, and depth. So when I write this constructor inside the class, whenever we create a box object, okay, it will create a box object with these initial values. So width will be 3, height will be 6, and depth will be 4. That's okay. So whenever I create an object, a box will be created whose width is 3, height is 6, and depth is 4. But the programmer who want to use this box class, if he want to give his own dimensions, so is it not possible? So how is it that every box will be of the same size? We want a box of different dimensions, and the dimensions must be given by the programmer who is creating the object. Okay. In such case, there is a method called parameterized constructor. Okay, this is the second type of constructor, parameterized constructor. The constructor that has parameters is called parameterized constructor. So you can see the example there. In this box, I am passing three parameters: double W, double H, and double D. Okay, W, H, and D are being passed, and we are initializing the instance variables width, height, and depth to W, H, and D. Width is equal to W, height is equal to H, depth is equal to D. Okay, so this allows the user to create a box with his own dimensions. Whatever the dimensions he wishes to give to the box, he can pass as the parameters. That is the advantage of parameterized constructor. Okay, we have seen default constructor or parameterless constructor in the previous example. Here we are telling about parameterized constructor, which allows you to create the objects with the given with the values that you want to give. Copy constructor. There is a third type of constructor known as copy constructor. So for example, I already had a box and I want to create exactly a box with the same dimensions, which is similar to this one. I want to clone a box which is similar to the box I had with me. Then to clone an object from another object, we use copy constructor. So that is, we give one object and we want to create an object exactly like that using the constructor. Then we say we are using copy constructor. The copy constructor takes objects of its class as parameter. So for a copy constructor, we are passing a parameter, but this parameter is nothing but an object. You can see that box OB. I am passing object OB of type box to this box constructor. Okay, and I am initializing the dimensions in this fashion: width is equal to OB dot width, height is equal to OB dot height, depth is equal to OB dot depth. Okay, then this will create a box whose dimensions are similar to OB. This is known as copy constructor. this will create an object with the same dimensions as the object that is passed. Constructor overloading. So in the last class, we have seen method overloading. Method overloading means a class can have more than one method with the same name, okay, provided their arguments are different. That is either the type of arguments or the number of arguments or the order in which the arguments were given, that is types were also exchanged. Okay. In the same way, constructors can also be overloaded. A class can contain more than one constructor in it. Okay. When we write more than one constructor, we say that constructors are overloaded. Constructors can be overloaded. In a class, more than one constructor can be declared. Okay. The constructors must differ in the order or type of parameters passed. The same rule for the methods and constructors also. When I am writing number of constructors in the same class, we know that the name of the constructor is the name of the class. That's okay. There is no return type. But with the parameters, the parameters should differ between the constructors. Let us look at an example for constructor overloading. Class box. Okay, I am creating the class box and they have got 3 dimensions: width, depth, and height. This is a default constructor. You can see box width is equal to 10, height is equal to 5, depth is equal to 3. So whenever you create a box using this constructor, the values will be initialized to 10, 5, 3. Okay. So you can see this box double W, double H, double D. This is a parameterized constructor. I am passing 3 parameters to initialize my variables. Okay. Width is equal to W, height is equal to H, and W is equal to depth is equal to D. That is parameterized constructor. So you see box S. I am passing an object of type box. Okay, which means this is a copy constructor. So we are initializing the values such that the width of S will be width of our box. Width of height of S will be our height, and depth of S will be our depth. This is copy constructor. In the same class, I got 3 constructors. So I am overloading the constructors. This is what we mean by constructor overloading. An example, a very good example for constructor overloading. Okay. So if I create an object in this fashion, box B1 is equal to new box, then this default constructor will be called. Box B2 is equal to new box 3, 4, 5. If I am passing 3 arguments, then automatically this constructor will be called. When I create an object like this, box B3 is equal to new box B2. B2 is an object of box. Okay. So automatically, because this is an object of box, it will match this constructor. So another box with the same dimensions of B2 will be created. This is a copy constructor. Okay, this is how we will create objects using the constructors. This is how we can overload constructors in a particular class. Okay. So let us go to Notepad++ and run this program. Okay, I want to create the class box. We remember that to create a class, we use the keyword class. And the class can have some attributes and some methods. Okay, and also the newly learned thing is class can have constructors. That's okay. We know the attributes in the box class, that is width, height, depth, and we defined one method in this, that is return type is double, which returns the volume, and the formula for volume of a box or a 3-dimensional object will be width into depth into height. Okay, so I have my method here, I have my attributes here. We can add our constructor there. Okay, what is the default constructor that will be there? The compiler, Java compiler will add a default constructor. I said that. Okay, the default constructor will be We know that the name of the constructor should be the name of the class, that is box. I'm not passing any argument there. Open and close. Okay, this is the default constructor. Okay. So if I want to initialize the box to some dimensions, you can say that width is equal to 2, depth is equal to 2, height is equal to 2. So whenever I create a box using this constructor, a box whose width, depth and height are 2, that is something like a cube will be formed. Okay, this is my box class. I want to write another class with the name main class and write my main method in this. By now you remember how to write the main, I believe. Public static void main string args. Let me create an object for box. Box v1 is equal to new box. Okay, so I am calling this default constructor box. When I call this default constructor, the object will be created whose dimensions will be 2, 2, 2. Okay, let me run this. I'm saving main class, save box class. Come here. So Java C, because the classes were in different files, I need to compile both of them. Java C box dot Java. Let me compile the box. Then again Java C main class dot Java. Okay, that is also compiled. Let me run Java. Okay, have I called the method main? I have not called the method. Let me call the method also. Dot out dot print ln v1 dot volume. Save it. Compile it again. Whenever you make a change, you need to compile it again. Java C main class. Then Java main class. We run. You can see that the output is 8.0. We can understand that when we get this 8.0, so it was 2, 2, 2. 2 into 2 into 2 will be 8.0. That box is created. Okay. Let me add another constructor in this. Parameterized constructor I want to add. We know that name of the constructor should be box. Let me pass the parameters. Double W, double height, that is H, double depth, that is D. Then I am initializing the width with W, depth as D, height as H. Okay. So whenever we use this constructor, I can say public. It doesn't matter. It can be package also. So public box. Then whenever I use this constructor, the object will be created with the given dimensions. You can give the dimensions whatever you want. You will pass 3 double values, and based on that, the box will be created. Save it. Remember that whenever you make a change, you need to compile. So I'm compiling Java C box.java. Then let me come back. Go back to the main class. Create another class, another object. Box v2 is equal to new box. Let me pass some values. 3, 5, 7. I can pass 7.5 because I have 7.5 or 7.6 double values, as I have initialized the values to double. Okay, just passing 3.1, 5.4. Let me find the volume of this particular system dot out dot println volume of V2 is plus V2 dot volume. Okay. Let me change this also. Let me add the string. Volume of V1 is, this plus is concatenation. I am concatenating this string with the output of this volume method. Okay. Let me run this. Save. I need to compile it. Java C main class, not Java. Java main class. You can see that the volume of V1 is 8.0, the volume of V2 is 125 point something. Okay, this is our volume. We can clearly understand that V2 is created with the dimensions given. We can pass a different set of dimensions to change it. We'll get a different value. Changing the dimensions I have passed. Let me save. After every change, you need to compile the program again and run the program. You can see that the output is 105, 105.5. Okay. So what is the third type of constructor we said? We have a copy constructor. Okay. Again, box, that is class name. So what is the input I need to get? An object of box P, let us assume. How to initialize the variables? Width will be equal to V dot width. Depth is equal to V dot depth, and height is equal to V dot height. Okay, this is our copy constructor. So in the same class I had a default constructor, parameterized constructor, and a copy constructor. So I am overloading the constructors. I can say that overloading constructors. Okay. Save. I need to compile this. I am compiling Java C box.java. So let me come here and create an object B3. Box B3 is equal to new box. Let me pass B2. So it should create an object which is exactly like V2. That is the same dimensions 3, 5 and 7 should be the dimensions of B3. So the volume should be same. Let me run this. So volume of B3 is equal to B3 dot volume. Save it. Compile the main class and run it. Java main. You can see that volume of B3 and B2 is same, 105.0, 105.0. Okay. This is about constructor, overloading and constructors. Let's discuss about the differences between the constructors and methods. Okay. So a method is used to expose the behavior of an object. Okay. We have seen that volume is the method. We need to find the volume of the box. Okay. That was possible through method. A method is used to expose the behavior of the object. A constructor is used to initialize the state of the object. So when I want to initialize the instance variables of the object, the variables are the state of the object, we can say, then we use the constructor. Okay. A method has a return type. We know that method must have a return type. A constructor must not have a return type. We cannot have a return type in constructor. The method is invoked explicitly. I need to call the method b1.volume. I am calling the method. Only then that method will be invoked. Okay. But I am not calling the constructor anywhere. The constructor is invoked implicitly. Okay. Constructor is not at all being called. Whenever I try to create the object using the keyword new, the constructor will be automatically invoked. The method is not provided by the compiler in any case. Okay, if you have not written any method in the class, what will happen? Nothing will happen. Okay, the class will be created without methods. But if you have written a class without the constructor, the compiler will create a constructor for you there. Okay, the Java compiler provides a default constructor if you don't have any constructor in a class. That is another difference we should remember. The method name may be or may not be the same as the class. Okay, if I want, I can create a method whose name is exactly name as the class. But when it comes to constructor, the constructor name must be same as the class name. So let us go to the next topic, garbage collector. So the name itself says that, for example, we created number of objects in our program. Okay, and these objects are stored in the heap of our system. Let us assume that there were number of objects created and we are not using those objects. Those objects must be cleaned to reclaim the memory that was occupied by them. When an object is not being used anymore, it should be destroyed. So garbage collection or the garbage collector in Java is going to take care of destructing the objects which are not being used. When we think of other programming languages like C++, okay, in C++ what happens is that the programmer has to take care of destroying the objects he created. Once he feels that he don't need the object anymore, then he must call the destructor on that. Along with the constructor, there is something called destructor in C++. When he constructs an object, after he uses the object, the programmer has to take care of destructing the objects also. If not, there is no automatic way of destructing the unused objects. But in Java, there is no explicit need to destroy objects as in C++. So deallocation of memory is handled automatically in Java. The technique that accomplishes this is known as garbage collector. So garbage collector is the one which takes care of freeing the memory whenever the memory is not being whenever the memory is getting full because of the unused objects, garbage collector will go there and clean all the unused objects. So garbage collector works like this. There is a question there: how a garbage collector knows that a particular object is not being used anymore that can be cleaned? Okay, so this is the answer. When no references to an object exist, that object is assumed to be no longer needed. Okay, if there is an object and there were no references being given to that object, then we say that that object is no longer needed and the memory occupied by the object can be reclaimed. Garbage collection only occurs sporadically during the execution of your program. For example, in your class you created an object and you believe that that object is no longer needed. Garbage collector is not going to come immediately and take it. Okay, that happens sporadically. It will not occur simply because one or more objects exist that are no longer used. Okay, so but whenever you feel that whenever the situation is that your RAM is being flooded with number of unused objects, automatically garbage collector comes into play and cleans all those unused objects from that. Okay, thank you.